In this video, we're going to learn about lambda expressions and see how we can use them to simplify functions that use local function definitions. We'll also see why we've had this little symbol in the corner of our slides all term. So here we go. The starter file I'm using here is lambda starter.racket, so you can download that from the course webpage. And lambda expressions are a new mechanism in the language, and so to get access to them, you need to switch your language level here from intermediate student to intermediate student with lambda. Okay? So here we go. It's yellow because I haven't run the file yet. I'll just run the file quickly to turn the yellow off. Now let's look at the problem that lambda expressions help us solve. Let's look at these two functions. These are again from the starter file. Let's look at these two functions, only bigger and all areas. Both of these functions definitions have a local function in them, here and here. And that local function is only used in one place inside the larger function. So pred is defined here and it's only used in one place. Area is defined here and it's only used in one place. So not only are these functions which are not used outside, that's why we define them with local, but they're also functions which are only used in one place inside the local. They're also quite simple functions. Functions where giving them a name doesn't make the code any clearer. When I look at this function, greater than n threshold, the body, is certainly more clear than the name pred. And even if I had named the function something like bigger question mark, greater than n threshold is more clear than that. So we've got a local function here that has two key properties. One is it's only used in one place, and the other is that the body of the function is so small that it's very clear to me what the function does. In cases like that, we can rewrite this a different way. What I'm going to do is I'm going to copy it. Oftentimes when we refactor, we like to copy to make sure that if we mess up, we can go back. And what I'm going to do is I'm going to take this whole part of the function, starting with the parameters, up to the end of the body. I'm going to copy that, and then instead of pred here, I'm going to put open paren, lambda, open paren, and then I'll paste what I copied. And I'll just change the formatting a little bit. I'll get rid of the local. And then I'll go comment out the original version. We'll delete it later. And I'll run my test to make sure I haven't broken anything. And I haven't. Those tests passed. So now let's see, what does this say? Well, the previous version said, define a locally defined function named pred with a parameter n, and here's the body, and call filter with that function. This version says, define a function with parameter n, and here's the body, and what this open paren lambda here means is it means define the function and don't give it a name. So what we have here is what's called an anonymous function, and we're calling filter with that anonymous function. And really what we're being saved here, and this is why the name anonymous function expresses what it is we're being saved the whole overhead of thinking of a name, defining the name, setting up the name, the lexical scoping, all of that which came from local and this define and this name is gone down here. Here we're just saying, look, there's no name involved. Here's a function without a name and you can use it one time. And so lambda is a good thing to use in cases just like this. Again, you have a locally defined function that you just use once, and the body of the function is so clear as to what the function does that when I read this, it says filter, and the predicate is for each n is n greater than the threshold over the list of numbers. That's more clear to me actually than when I read it up here. So lambda is a good tool to use for cases like this. It simplifies the code, makes it a bit more clear. Of course, what I should do when I'm done here is go ahead and delete this. I didn't delete it before so that we could use it to compare the two. But normally when you're done refactoring the code to use lambda, you would delete the old version and of course run the tests one more time. Okay, there we go. That's lambda and how to use it. There's two more exercises in this file, functions that are amenable to using lambda. There's all areas and then there's qsort. What I'd like you to do in just a second here is pause the video and then go ahead and do these two exercises yourself. And then you can start the video again. And when the video starts again, I'm just going to quickly go through the solution to them so that you can see how I do the process of the edit in those two cases. Stop the video now. Okay, I hope you've had a chance to refactor all areas and qsort to use lambda. I'm just going to go through and do it myself now. Okay, as always with a refactoring like this, I like to start with a copy just to make sure I don't mess up. Area has one function in it. I'll just take the parameter and the whole body of the function, replace the name here with lambda, the whole body like that. Fix the space a bit, get rid of the local, Command I to fix the indentation. Looks good. Let me run it. It's passing. So this just says map for every image in the list, multiply the image width times the image height. Okay, I'll get rid of this one. Now let's look at qsort. Let's see, qsort has two functions in it. So we'll copy this one here. We'll go to that use of the function and say open paren lambda. And then we'll get this one. Open paren lambda. We'll get rid of those two functions. We don't get rid of the whole local this time because we still need this local variable p. Let's try running that. Okay, so there you go. You have three examples of how to use lambda to simplify functions where there's a locally defined function that's only used in one place and the body of the function is quite clear. Lambda is a great tool for simplifying functions like that. Oh, and one last thing. If you want, instead of typing out lambda like this, you can type on Windows you type Control \, on the Mac you type Command \, and you get a little lambda symbol like this one. And you can use that everywhere that we were using lambda, and it means exactly the same thing. And that's why the logo that we're using for this course and the logo that we got from the Dr. Racket project looks like a lambda expression. It's what they call their steal your face lambda, which you can Google that to see what that's about. If you want, you can also Google something called the lambda calculus, which is a foundational concept in programming languages that underlies our understanding of programming languages and computation in general. That's something you can learn more about in other courses. Anyways, there you have lambda expressions and how they can be used to simplify certain programs.